Good morning, children. Today I am going to explain the questions of functions. Here we have to prove that the function is 1, 1 and onto. So using theoretical method also we can prove this. F of x is given to us. It is 3 minus 4x. So f of x is 3 minus 4x. We will find out the f of x1 and f of x2. So f of x1 is 3 minus 4x1. Just replace x by x1. So write f of x1, it is 3 minus x1. Similarly, we can write f of x2 as 3 minus 4x2. So 3 minus 4x1 and this is 3 minus 4x2. Now equate these two values. F of x1 is equals to f of x2. So whenever we have to prove that the function is 1, 1 function, we will start with this step from given f of x. We will find f of x1 and f of x2 and equate them. F of x1 equal to f of x2. And substitute the functions 3 minus 4x1 equal to 3 minus 4x2. Cancelling 3 from both the sides and minus 4. Then we get x1 equal to x2. So when we start with f of x1 equal to f of x2, we should get x1 equal to x2 only this value. Not other relation between x1 and x2. And when we get x1 is equals to x2, then we can say that the function is 1, 1 function. Understood? These are the steps to prove that the function is 1, 1 function. Now, to prove that it is onto, we will consider f of x as y. So, consider f of x is equals to y, that is 3 minus 4x is equals to y. Now, here we will write this relation in terms of x, that is x in terms of y. So shift x term 4, that is minus 4x term to right hand side. 3 minus y equal to 4x, and now we get the value of x in terms of y as 3 minus y upon 4. Okay, so we'll consider f of x is equals to y and then find out the value of x in terms of y. Then put this value of x in f of x. So here we will substitute the value of x in f of x. So here we will substitute. Okay. So we get f of 3 minus y upon 4 is equals to 3 minus 4x. So substitute this value of x. It is 3 minus y upon 4. Cancel 4. 4 will get cancelled. That is 3 minus 3 plus y. So we get y. So we should get f of x is equals to y. So when we prove that f of x is equals to y, the function becomes onto. Hence here we can write, therefore the function f of x, the function is onto function. So it is the onto function. So these are the steps to prove that the function is onto. In the next question, the function is defined from R to R and f of x is 1 plus x square. Okay, again let us start with f of x1 and f of x2. x1 and x2 belongs to R, that is set of real number. Consider f of x1 and f of x2 and equate them. Here f of x1 will be 1 plus x1 square and x2 will be, f of x2 will be 1 plus x2 square. So 1 plus x1 square equal to 1 plus x2 square. Cancelling 1 from both the sides, we get x1 square minus x2 square equal to 0. Open this. Here expand using the formula x1 plus x2, x1 minus x2 equal to 0, equate each bracket with 0. And here we get the two values, that is x1 is equals to minus x2 and x1 is equals to x2. Okay, so here we are getting two values and x1 equal to minus x2 we have to accept because it is defined on the set of real numbers, there negative numbers are there. And when we get two different values of x1, that is x1 equal to minus x2 and x1 equal to x2 also, then we can say that f is not 1, 1 function. So in this case, f is not a 1, 1 function. Okay, and now we'll check whether it is onto or not. Here we'll find the range of f. Range of f, so function is 1 plus x square. Whatever the value of x is, either positive or negative or fraction, 1 plus x square, its square term will be a positive term. And adding 1 to it. So this value is always more than 1. Okay, so f of x is always more than 1. Hence, in this range, we get all the positive values which are 1 or more than 1. When x is 0, then in that case it will be 1. Okay, so range of f contains all the numbers, positive numbers, more than 1, all real numbers more than 1. Here we can write, see the Venn diagram. This is the domain set. Here there are positive values, negative values, 0, set of real numbers. We can relate 0 to 1 because image of 0 is 1. When we substitute x equal to 0, 1 plus 0 square, we get 1. Minus 1, when x is minus 1, then value of, that is its image, is 2. F of x will be 2. When x is equals to 1, it is 2 again. 1 plus x square, 1 plus 1 square. Okay, so minus 1, its image is 2. 1 image is 2. So from this it is clear that it is many one function, it is not a one function. Okay, similarly when x is 2, then its image will be 5 in the codomain set. Now codomain is the set of real numbers. This is the set of real numbers. Here there are positive as well as negative numbers, fractions also. So negative numbers in this set, they are not the images of any element in the domain set. So here whatever the negative numbers are there in the codomain, they do not have any pre-image in the domain set. Okay, hence this range and codomain are not equal. Range is not equal to R, hence it is not a onto function. This is not onto. In this example, function f is defined from the set A to B. Set A is the set of real number except 3, R minus 3. Set B is the set of real numbers except 1, R minus 1. And the function is defined from A to B as f of x is equals to x minus 2 upon x minus 3. Here also we have to check whether the function is 1 onto or not. So f of x1 equal to f of x2. We'll start with this step. F of x1 equal to f of x2. From this f of x we can write f of x1 as x1 minus 2 upon x1 minus 3 and f of x2 as x2 minus 2 upon x2 minus 3. See here this step. So equate these two, f of x1 equal to f of x2, cross multiply. By cross multiplication we get x1 x2 minus 3x1, open the bracket, you will get these terms. So these are the terms after opening the bracket, after finding the multiplication of the two brackets. And here we can cancel x1 and x2 from both the sides directly. 6 from both the sides, cancel 6 from both the sides, and we get x2 minus x1 equal to 0, that is x1 equal to x2. No other relation between x1 and x2, only x1 is equals to x2. Whenever we get this step, we can say that the function is one function. Okay, so in this way we can prove it is a one function. Then consider f of x is equals to y. Y is equals to x minus 2 upon x minus 3. Here we need to find the value of x in terms of y. Okay, cross multiply y x minus 3y equal to x minus 2. Collect x term on the left hand side, take x common, x into y minus 1 equal to 3y minus 2. We get x is equals to 3y minus 2 upon y minus 1. Okay, this is the value of x. We will put this value of x in f of x. Okay, so what is our f of x? Here the function f of x is x minus 2 upon x minus 3. Here we will substitute that value of x, which is in terms of y. Okay, so f of x is 3y minus 2 upon y minus 1 minus 2. This is x minus 2 upon x minus 3. So substitute the value and simplify this. Here we have to simplify by cross multiplication. 3y minus 2 minus 2y plus 2. Okay, and in denominator also you simplify this. After getting directly, we can cancel this y minus 1 In numerator 3y minus 2y is y. 2 also directly we can cancel from numerator. In denominator 3y plus positive negative 3y also we can cancel. So what is left? F of x is equals to y. So we should get f of x is equals to y whenever we have to prove that the function is onto. So here we get f of x is equals to y, hence the function is onto function. So children, in this way we can prove that the function is 1, 1 and onto. So these are the steps for proving or finding whether the function is 1, 1 and onto or not.